And you did some
So
experiments in mice that were really interesting, I
that's
thought.
right. That's right. So I mean, maybe we should just think about what's changed in the diet first. So if you think back to the 1920s, 1930s, so what's happened through time is there's been a big reduction in the amount of fat that we eat. Sorry, in a big increase in the amount of fat that we eat. So there's been a change that we've slowly increased the amount of fat. We've also increased the amount of sugar that we eat. But the biggest change is probably the calories we're deriving from fat. But it's not a constant composition of fat. So what's happened is at the same time that we've increased the total, we've actually reduced the proportion of that total that's saturated fat.
Mm,
So in the 1920s, we were probably 90% of our calories in fat were coming from saturated fats that are coming from butter and lard and things like that. In the 1930s to 50s, we got this takeoff in unsaturated fat, principally coming from sort of seed oils. And that has now grown to really dominate our intake. And so now the saturated fats are only about 16% of the total. And so we were interested in whether those shifts in the fatty acid content of the fats that are eaten could be an important
mhm.
driver of the metabolic rate. And we
I mean,
actually have,
and if I
yeah,
heard you right, that's quite a remarkable shift. You go from 90% of the calories of fat coming from saturated fat at the beginning of the 20th century down to, below 20% today.
yes, that's right. So it is an enormous change. And but it's overlaid on the background of the total is going up as well.
Okay.
So actually, if you look at the actual amount of saturated fat that's being eaten, it's declined, but not anywhere near as much as that percentage
I see.
suggests. So we're not going from eating like 90 pounds of lard a year to 16. It's a much smaller effect, but percentage wise, that's what's happening. And most of that extra that we're eating is mostly polyunsaturated fat, principally linoleic acid.
Hmm.
So there is that big move. And so what we were interested in is whether
And so,
that,
sorry, but before we go forward, the linoleic acid piece, is that primarily coming from is the driver of that change because we came up with ways to mass produce things like vegetable oils and they
yeah,
just became cheap and easy to get?
yeah, principally. But also there was, of course, a sort of a health drive as well going on. So it wasn't just availability, it was that people uh, were told that eating saturated fat is not good in terms of heart disease, and that limiting your saturated fat intake is probably a good idea. So there was a sort of shift towards, away from butter to margarine. Those sorts of things were happening through the 1960s and 1970s. It's interesting, though, that we might think that that was all driven from the sort of work that was done in the 1950s. But if you look at the data, the decline in the percent of fat that's coming from butter and lard, it starts much earlier. It starts in the 1910s,
Hmm.
1920s. And we're not really clear why that is, but it was already happening. It wasn't just like, Ansel Keys came along and said, look, it's really bad eating butter, and people stopped eating it. It was a gradual trend that, in fact, there was no acceleration during that time period, that it just continued on that same sort of trend.
Hmm.
And we increased all these alternative sources. And they're kind of also a lot of hidden fats in food, because we use those in processed foods and things like that. So we did this mouse experiment. So one reason to do a mouse experiment is because it's very easy to control what they eat. So the problem with working on humans is you can tell them what to eat, but they have a choice to go away and eat it or not eat it.
Mm-hmm.
And so you never really know when they come back into the lab whether, the experiment worked or not, unless you keep them captive for a
Mm-hmm.
long time. But a
And I would,
mouse you can keep captive.
yeah, I would imagine as well that for some of these diet induced changes in metabolism, they probably don't happen overnight. They might require extended
No, right,
periods.
right. Yeah, right. So when we did the mouse experiment, actually the mouse experiment was done by some guys at Yale, and they did an experiment that's about 3 months long. So it's equivalent to about 11 years in a human. So it's it's a good amount of time. So if there are changes going to happen, then you expect to see them. And what they found was that the change in the metabolic rate was mostly related to palmitate. So palmitate's a saturated fat. It's the biggest component in butter and lard. It's palmitic acid. So that was pretty interesting because that's the thing that's relatively gone down over time. And so it was consistent. These changes that we observed in the mice were consistent with the change through time in the human diet and the slow decline in the metabolic rate through time. So it was kind of all fitting together.
Okay, so higher intake in mice of the saturated fat correlated with more energy expenditure.
Yes. And higher intakes of polyunsaturated fat in general, but the major amount of that was linoleic acid, which is also the major component in the human diet. They would correlate it with lower metabolic rate. So there have been some studies in humans that have tried to look at this, and they paint a sort of fairly mixed picture. So there are some intervention studies lasting a couple of weeks that suggest maybe there's an increase in relationship to linoleic acid intake. There's some other studies that suggest there's no change, but it may be just the study's not long enough, so it's difficult to tell. In terms of the mice, we'd actually already done a study in 2007 in my own lab where we fed mice different diets with different fat proportions. And we looked for the relationship between individual variability in fatty acid composition of the membranes of the livers and what the metabolic rate was. And we showed that palmitate was in the liver was a major driver of metabolic rate in the same direction as what we found in the other study.
Interesting. So more saturated fat, specifically palmitate, more energy expenditure.
So that's what we found in the mice. And at the moment, we're sort of designing experiments to see cross-sectionally whether that's true in humans. So if we can look at human diets and find out what people have been eating, measure their metabolism, see whether there's a correlation there, and then try and do some intervention studies. But it may be difficult just doing intervention studies that are kind of long enough.
Mm-hmm. And so from the 90s to the present, basically, the period of time that you have data with your doubly labeled water experiments, those experiments, again, they showed a decrease in total energy expenditure, which you just told us is mainly coming from a decrease in basal expenditure. Do we know anything?
Only coming from a decrease in basal. Yeah, because activity expenditure seems to be actually going up slightly.
Yeah. So it's gone down. Total has gone down despite that because there's been such a drop in basal expenditure. Yeah. Over that period of time, do we have good data anywhere?
Sorry, I'm going to cough here. Yeah, okay.
Do we have data on total caloric intake? Like, are we actually eating more calories per day today than we were in the 90s?
Yeah, good question. So I think that's extremely difficult to answer. I mean, the problem is measuring food intake is incredibly difficult. And the tools that we have available to do that are not really good enough to answer the question. So there was a paper recently suggesting that actually intake has been pretty flat through time for the last 20, 30 years. I'm not convinced that that's correct. If you look at food supply into the population, that's definitely gone up. And so either the waste levels have gone through the roof or we're consuming that food. And I think it's probably a combination of both, that we're probably wasting more. But I think on balance, we probably are eating significantly more calories than we were 30 years ago.
So, in other words, if that is true, that would obviously mean it's possible for a population to simultaneously decrease their baseline energy expenditure and consume more calories.
Yeah, absolutely. And I think probably the major factor driving the obesity is probably that increase in the food intake rather than the reduction in the basal metabolism. So the reduction in the basal may contribute, but I don't think it's the primary driver.
Mm-hmm.